Hello viewers and welcome to Engineers Mindset. So in this video, I'm going to be showing you how to differentiate sin x from first principle. Alright, let's do this and see. You're given y equals sin x and you have to find dy dx from first principle. First thing to do, when y increased by change in y, so y plus change in y, this will cause a corresponding increase in x by change in x. So I have simply sin x plus change in x. So if y increase by change in y, of course x will also increase by change in x. Now recall that sin a plus b is equal to sin a cos b plus cos a sin b from trigonometric identities. So this simply implies that sin x plus change in x can also be written simply as sin x cos change in x plus cos x sin change in x, and you have this. Now let's plug this into this equation in place of sin x plus change in x. So the equation becomes y plus change in y. This is going to be equal to, in place of sin x plus change in x, we put in this value. It becomes sin x cos change in x plus cos x sin change in x, and you have this. What next? We want to find the y over the x, so it makes more sense for me to leave change in y over this side. So simply transfer y to the other side of the equation. Therefore you have change in y is going to be equal to, this becomes sin x cos change in x plus cos x sin change in x. Now if positive y cross and equal to sign, it becomes negative y. So I simply have this, but not forgetting earlier we said y is equal to what? Sin x. That's the given question. So in place of y here, we simply put in sin x. So the equation becomes change in y equals sin x cos change in x plus cos x sin change in x minus, in place of y we have sin x. Now I have sin x here and I'm having sin x here, so let's bring them together. Therefore change in y is now equal to, this is sin x cos change in x, now minus sin x, so I have plus cos x sin change in x, and you have this. Now since sin x is common between these two, let's factor sin x. So change in y is equal to sin x is common into cos change in x minus 1 plus cos x sin change in x. So observe that sin x multiplies cos change in x. That simply gives us what? Sin x cos change in x. Again, sin x multiplies by negative 1. That gives us negative sin x. So which means our equation is in order. So at this point, we divide all through by change in x. So this becomes change in y all over change in x equals, I have sin x into cos change in x minus 1 all over change in x, okay, plus I have cos x sin change in x all over change in x, and you have this. Okay, so what I will do at this point, as I explained in my previous video on how to differentiate cos x from first principle, so I will do well to post a link in the description of this video, so do well to also watch that link to also understand how to differentiate cos x from first principle. Now in that video I said, when you get to this point, do not take your limit immediately. What you do is simply multiply this side of the equation alone by the conjugate of the numerator. The numerator here is cos change in x minus 1. Therefore, the conjugate becomes cos change in x plus 1. So simply multiply top and bottom by that conjugate. So I'm going to have that change in y all over change in x becomes equal to, now I have sin x outside multiplying by cos change in x minus 1 all over change in x. But I will simply multiply both top by the conjugate of this numerator and also bottom by the conjugate of this numerator. So that becomes cos change in x plus 1 all over cos change in x plus 1. I have this, okay, plus, now on this other side, I have cos x sine change in x all over change in x. So plus cos x sine change in x all over change in x, and you have this. Now, if you observe, cos change in x plus 1 divides cos change in x plus 1 is more or less 1, just like saying 2 all over 2, which still remains 1. So I am invariably multiplying this whole equation by 1. So which means it is mathematically what? In order. Because if I multiply everything here by 1, the value still remains what? Everything here. Okay, so change in y all over change in x is equal to, I have sine x here. Now let's expand this bracket. Cos change in x multiplies cos change in x. That gives us cos squared change in x. Again, cos change in x multiplies plus 1. That gives me plus cos change in x. Similarly, negative 1 multiplies cos change in x. That gives me negative cos change in x, and negative 1 multiplies plus 1, that gives me negative 1. Close your bracket, divide through by, now this becomes change in x multiplying by the denominator here, which is cos change in x plus 1, and you have this. Then put down what you have here, plus cos x sine change in x all over change in x. Okay, so let's see what can cancel out. Change in y all over change in x is now equal to, I have sine x multiplying through by, I have here cos squared change in x over here, but observe cos change in x minus cos change in x is off, that's 0. So you put down your negative 1 all over, this is delta x multiplied by cos change in x plus 1. Okay, so you have this. Put down what you have here, plus sine plus cos x sine change in x all over change in x. At this point, you recall another trigonometric identity which states, recall that cos squared change in x plus sine squared change in x is equal to what? 1 from trig identity. So which means we can make cos squared change in x subject and obtain a value for it in place of here. Alright, so this simply implies that cos squared change in x is going to be equal to simply sine plus sine squared change in x over to this side of the equation. Positive sign cos and equal to sign becomes negative. So I simply have 1 minus sine squared change in x. So in place of cos squared change in x, the value remains 1 minus sine squared change in x. So let's plug it and see. We have change in y all over change in x to now be equal to, this is sine x. Now multiply through by, in place of cos squared change in x, we put in this value 1 minus sine squared change in x. Remember, there is a negative 1 here. So minus 1 all over change in x multiplies cos change in x plus 1. And you have this. Okay. Now plus cos x sine change in x all over change in x. Okay. All right. So change in y over change in x is now equal to, I have sine x into, now observe, 1 minus 1 cancels out, that 0. So you're left with negative sine squared change in x all over change in x multiplies cos change in x plus 1, and you have this. Okay, plus, now you have cos x sine change in x all over change in x. Okay, so let's see what we can do concerning this term in the bracket. All right, so we have change in y all over change in x to now be equal to, I have sine x into, so let's break this part of the equation a little bit. Sine squared change in x can be written simply as minus sine change in x multiplied by sine change in x all over change in x into cos change in x plus 1. All right, so the numerator is basically the same. All I did was expanded sine squared. So sine change in x multiplied sine change in x, that gives us sine squared change in x. All right, plus cos x sine change in x all over change in x. Okay, so change in y over change in x is equal to sine x. Now, let's break this once more. So, I'm simply going to have sine change in x all over change in x multiplied by negative sine change in x all over cos change in x plus 1, okay, plus cos x sine change in x all over change in x. So let's just bring sine change in x over change in x together, just like we did here, sine change in x all over change in x together. Okay, so this is now still the same thing as this. Of course, sine change in x over change in x times minus sine change in x over cos change in x plus 1. So if you multiply the numerators together, sine change in x times minus sine change in x, that gives us what? Negative sine squared change in x. Then multiply denominators together, change in x multiplies cos change in x plus 1, we simply have this denominator. So I just split it. It's basically what? The same thing. Okay, now at this point, you can now apply your limit. At this point, you can simply apply your limit. And what's the limit? The limit as change in x approaches 0, this function change in y all over change in x approaches what is called the y all over the x. Okay, so that simply means that if you take this limit, then change in y over change in x ceases to become change in y over change in x. Rather, it becomes what? The y all over the x. So therefore, the y over the x is going to now be equal to, I have sine x multiplied through by the limit as change in x approaches 0. So I am doing this for all the terms that contains change in x. That is why I did not put in that limit or effect the limit over here where I had sine x. Okay, so it becomes limit as change in x approaches 0 of sine change in x over change in x multiplied by same thing here, limit as change in x approaches 0 of negative sine change in x all over cos change in x plus 1. Okay, you have this. All right, now plus this is cos x. Now limit as change in x approaches 0, I am having sine change in x over change in x over here. So I have sine change in x all over change in x. So we simply apply the limits to all the terms that contains what? Change in x. So in the previous video, when I did how to differentiate cos change in x from first principle, I explained how the limit as change in x approaches 0 of sine change in x all over change in x is equal to 1. This is from L'Hopital's rule. So I explained this in that video. Do well to watch that video as you're going to see how this is equal to 1. I explained the procedure using the L'Hopital's rule. But keeping it in mind, limit as change in x approaches 0 of sine change in x over change in x, the value is simply equal to 1. So that simply means for this part of the limit, I am simply going to put the value as what? 1. Similarly, for this part of the limit, where I have sine change in x over change in x, I will simply put in the value as 1. Okay, if I do that, then the y all over the x is going to be equal to, I have sine x outside here, multiplying through now by limit as change in x approaches 0 of sine change in x over change in x, that limit gives us 1. So we have times 1, okay? Once again, multiply by, in this case now, I will simply put in the value of my limit as change in x approaches 0. So wherever you see change in x in this equation, put in the value simply as 0. So I have minus sine change in x. In place of change in x, that becomes minus sine 0 all over, I have cos change in x here. In place of change in x, putting the value as 0, so it becomes cos 0, not forgetting I have plus 1 there, plus 1. Okay, plus I have here cos x multiplied through by, now this is limit as change in x approaches 0 of sine change in x over change in x, and that value is 1. So this is cos x times 1, and you have this. All right, so dy dx is equal to sine x multiplied by, now 1 times everything here, of course remains everything here, but keep in mind sine 0 is 0 and negative sine 0 of course is going to be 0, so you simply have 0 all over, now cos 0 is 1, 1 plus 1 is 2, so I have 0 all over 2 plus, over here cos x times 1 still remains cos x, so this is equal to 0 over 2, of course is 0, 0 times sine x is 0, so I have 0 plus, put down your cos x. All right. So from here, it is clear that dy all over the x is going to be equal to, of course, 0 plus cos x still remains cos x. So if y is equal to sine x, dy dx is equal to cos x. All right, guys, so that's it on how to differentiate sine x from first principle. I know you love this video. Please do well to show that by liking our videos, commenting nicely, sharing to your friends, and of course, if you're new to the channel, do well to also subscribe to the channel. I will see you in the next video. Thanks and cheers.